Hey, welcome back to the Game Dev Engineers Super Duper Study Sheet. And today we are talking about alignment. So alignment is, it's another one of those topics, man. It's another one of those topics. Let's get into it. So the size and alignment boundaries, they're going to be different for 32-bit systems versus 64-bit systems. However, the only things that are going to change are long and pointer. So that's something to remember. I usually think, oh, to switch it over, that's going to be a long process. I say long process, and as a mnemonic that makes me remember long process, long pointer. So if I can remember long and process, I can remember long and pointer. So that's how I do it. Your mileage may vary. So the other thing to remember is that 8 bits is going to be 1 byte. So if you see a byte, it's going to be representing 8 bits. You just got to memorize that. Character is 1 byte, short is 2 bytes, int is 4 bytes, and then a long could be 4 or 8 bytes. Now, 32 bits is the, so on a 32-bit system, x84, that's going to be a maximum of 4 bytes. On a 64-bit system, it's going to be a maximum of 8 bytes. Not necessarily 8 bytes. So what that means is if somebody says, I'm working with a x64 processor, and I'm going to be using a long, how big is it going to be? Is it going to be 4 bytes or 8 bytes? You don't know. You know that it can be at maximum 8 bytes. That's all you know. And so, I mean, if it's 4 bytes, then it's basically just an int. But it could be up to 8 if it's on a 64-bit processor. Okay, the other thing to know is that a byte is always going to be 4 bits. We just talked about, sorry, a float is always going to be 4 bytes, and that's something we just talked about up here in the previous video. Okay, so a double is going to be 8 bytes, but 4 bytes on Linux. So a bit of a weird thing there, but there's a double asterisk here, which is that doubles use floating point arithmetic, just like floats do. So a double, so basically, you know, you could say, okay, an 8-byte long and an 8-byte double, what's the difference? They're just numbers, right? Well, no, because an 8-byte long is going to use the 2's complement like an integer. However, a 8-byte double is going to use floating point like a float. So that's the difference between those two. And then the other thing is, oh, I forgot, the pointer, which is the pointer can be 4 or it can be 8 bytes. So this is actually kind of curious because if you're on a x84 32-bit system, sorry, x86 32-bit system, what that means is that the pointers can only be 4 bytes long, which means you're going to have a limited amount of RAM because the pointers can only point to so high of an address. So actually, 32-bit registers can only reference about 3.5 gigabytes of RAM by nature of that. So it's just an interesting thing to note there. And then the other thing is that I hate these words. I mean, people pretty much never use them, but a half word or a double word is going to depend on you know, what system you are. That will be dependent on your processor. It's processor dependent, and they should be underlined. Okay, so the other thing to note is that people pretty much never use these because they suck, right? Because you don't know whether or not it's going to be 4 bytes or 8 bytes. So pretty much everybody's going to use fixed width data type. So it's going to look something like this: int 64. So you know that there's going to be 64 bits in this int. That's really the way you should do it. Okay, so talking about the PS4 architecture, this is very common when you're working for a studio like Naughty Dog or, you know, the other one. The PS4 architecture, you know, just talking about, you know, what's a bus, what's a cache line, what is the processor, stuff like that. Just understanding that it's going to take a lot more cycles in order to reference the L2 cache that's not associated with whatever the memories you want to grab. And, you know, the L2 cache system is going to be much closer then you're going to have the cache line, which is the quickest reference, then the L1, then the L2, and then finally you could go to main RAM. When you grab a chunk of data, it's going to come in 64-bit cache lines, which is considered hot data. Okay, so I think that's everything we wanted to represent there. Now we get to the fun test part, which is they're going to give you a struct, and they're going to ask, where is the padding for this struct? So in this case, we have a struct that is a total of 8 bytes. It's got a character, which is 1, a short, which is 2, an int, which is 4, and then a character, which is 1. And so that sums to 8. However, if you took this structure and you plugged it in, is it going to be 8 bytes? No, it's not. It's going to be 12 bytes because there's going to be padding added in. The padding is going to be added here and here. Okay, why is the padding added there? Well, the reason why the padding is added there is because you need to align the data for the next value. So a short needs to be 2-byte aligned because it's 2 bytes, right? We just talked about that. And so if you end on, if you do the first thing, you got 1, then you need basically 1 more bit in order to get to a index, which is going to be, you know, a factor of 2 in order to get the 2-byte alignment. So similarly, in int, it needs to be 4-byte aligned. So in this case, you know, that's not an issue. But, you know, if you put an int right after a character, you're going to need to have 3 padding in between. So what's pretty common is for you to group all the smallest data structures at the top. So you might have something like this. And this arrangement is actually going to lead to no padding because you're going to have 1, 2, and then the short is going to start in the 3, which is going to be naturally 2-byte aligned. And then the integer is going to go right after that. So you have 4 bytes right here. And so then the integer would naturally slot into the second thing because it's almost as if this was just one integer. Okay, so that's a rough crash course on padding. But there's something to note, and that's that the last 3 bytes of padding here are that's processor dependent, I'm pretty sure. So you don't necessarily know that there's going to be 3 bytes of padding, right? So for example, I was just doing a little test on that. Like, here's a fun question for you to play at home. Let's say we have a mixed data struct here that just has a character. How big is this struct going to be? Is it going to add 3 bytes of padding? In this case, no. This is going to be just 1 byte. So there's a bit of a question there of when does the padding come in, right? Like, who's to say what after it, you know, has to be aligned? So for example, if we add in an int here, in x or in c, whatever, what's this going to be now? Well, it's going to be 1, and the int needs padding in order to be 4-byte aligned. So there's going to be 3 bytes of padding here. So, you know, this structure is really just representing 1 byte and then 4 bytes of data. However, it's going to be 8 bytes in total because of the padding that's added there. Now, there's actually a way to say, hey, man. Where am I? Here we go. You can say, hey, man, don't pad this struct. And you can do that by just using this code here. So if you just slap a pragma pack 1 on it, it's going to, you know, pack everything to 1 byte alignment. And so the result of that, where's my output window? Oh no, that's not good. Let's try that again. Here we go. So this struct, sorry, so this is going to be, oh, that's weird. So this is going to be 8 here. Why is that? Damn it. I don't know. Huh. All right. Well, that was a bit surprising for me. I just consulted with Stack Overflow, though, and I learned that I don't understand Pragma as well as I thought I did. So instead, what you should do is you should wrap it with Pragma push, 1, and Pragma pack pop. For some reason, that will get me the 5 that I was looking for, but the other one didn't work. So I think that's kind of interesting. So I'm going to update my guide with that. But in conclusion, you know, besides that mistake I made, that's all you're going to really be quizzed on when it comes to alignment. So I would recommend just creating a struct in C++, taking a guess at what you think the size is going to be, and then, you know, pushing play, and then seeing what the actual size is so that you can accurately test yourself with respect to what the padding is going to be. And I think that's the best way to just get a handle on alignment. So good luck on that, and I'll see you in the next video where we talk about bitwise operators.